Fatima from Harmony Public Schools. Did you know that there are two scientists with completely opposing theories? Aristotle and Galileo are two famous scientists who had completely clashing theories. Aristotle thought that the weight of an object is directly related to the rate at which that object falls down to Earth. He demonstrated this with a piece of paper and a rock. He would drop these rocks, the rock and the paper, from the same height, and the paper would fall down slower than the rock. He would explain that this was because the rock was weighed more than the paper. Galileo saw this and said, if that was true, then how come if you take two papers that are the same weight, but you just crumple the other one, the crumpled paper falls down faster than the uncrumpled paper, even though that they weighed the same? Why is that?
Aristotle introduced his theory first. He believed that the weight of an object is directly related to the speed at which it falls down to Earth. He got people to believe him with his rock and feather demonstration. Later, Galileo came along and told him that he was wrong. Well, this was almost 2,000 years after Aristotle's time. Galileo would have been speaking to a skeleton. So he was actually trying to convince Aristotle's followers and not Aristotle himself. He convinced them that weight had nothing to do with it by going on the top of the Leaning Tower of Pisa and dropping a big rock and a tiny rock. As they both fell down to the ground at the same time, this proved that height, not weight, was directly related to the rate at which objects fall down to Earth. Galileo still had to explain to the followers why the feather and rock demonstration still worked. Galileo introduced his theory of air drag. Air drag is the forces that are in opposition to the relative motion of an object through the air. He proposed that in a vacuum, or a place without air, and therefore also without air drag, a feather would fall at the same rate as any other object.
To prove Galileo's theory, nowadays you can use a vacuum. In this tube, there's air, and there's also a feather and a coin. When you flip it, the feather falls down slower than the coin. To take out all the air, you use a vacuum. There's still some air in it. To take out all the air would be impossible, but this tube is partially vacuum. As you can see, the feather and the coin fall at the same rate. Because we took out the air, there's no air drag. In Galileo's time, he didn't have a vacuum. So, to prove this, he could put a piece of paper on top of a book and drop them. The book would be preventing the air from getting up under the paper and causing air drag. The paper in the book fell at the same rate because the air was prevented from acting on the paper and causing air drag to the paper. Thanks, Harmony Schools, and for more information, visit my website.